All right, what we're doing today is elimination and substitution. Chapter 3.2, we're doing algebraically how to find the intersection point between two equations given you're lining up your x and your y's. Elimination and substitution, you may have started to do some of this in Algebra 1. You may have. Hopefully you remember it. It should not be difficult for you. Equations have to be lined up. ax1 plus bx1 equals c, ax2 plus by2 equals c. This is equation 1, this is equation 2. Yes? A, B, and C, A and B are your coefficients, C are your constant. You have to line them up. If they're not lined up, it does not work well. Okay? Your goal is to examine the coefficients of the variable, determine which variable is easier to eliminate by finding the least common multiple of each variable. Coefficients must be opposite of each other. The opposite of 5 is -5. So if I have a 10, I have to have 10 and -10. If I have -2, I have to have +2. You with me? And then they cancel out. So here's a bunch of steps, but we're going to do it together. You guys can read those steps as we go. I'm not worried about that. So the very first thing you're going to ask yourself is step 1. Are my equations lined up? X's over X's, Y's over Y's. Equals over equals, number over number. Yes. The next thing we're going to do is we're going to find the least common multiple of my x's. My x's are 3 and 2. What are the first multiplication tables that they have in common between 3 and 2? 6. So I have to have plus and minus 6 if I eliminate x. What is the least common multiple of my y's? Well, my y's are going to be 3 and 4. So what is that going to be? What's my first multiplication table in common between 3 and 4? 12. Which one do you think is easier? 6. So we are going to choose to eliminate x. We all understand that. So I need to have a positive 6 and a negative 6. So how do I turn 3x into a positive 6x? Multiply the entire equation by 2. So if I'm going to make that a positive 6, I have to make the bottom one a negative 6. So what do I multiply 2x by to obtain a negative 6x? -3. So multiply the top equation by 2. That gives you a 6x plus 8y is equal to the bottom equation. That's going to make that a negative 6x minus 9y is equal to negative 21. And simply add straight down. The x's cancel out. I'm left with negative y is equal to 2 minus 21 gives you negative 19. So y is going to equal positive 19. Yes? Do you remember that? So now that I found y, how do I find x? Plug and chug into one of the original formulas. So I'm going to take 3x plus 4y is equal to 1. And 3 times 19 plus 4y is equal to, no, I just lied. I plugged in the wrong one. 3x plus 4 times 19 is equal to 1. I had a hot second. 4 times 19 is? It is 76. Subtract the 76. 3x is equal to negative 75. So what does x equal? X equals negative 25. So my POI is the ordered pair negative 25, positive 19. Do we understand that? I feel like it's faster to do this than what it is to solve each equation for y and graph it. Make sense? Again, what do you do first? Are they lined up? Next, LCMs. What's my LCM of my x's? Nope. The first multiplication table in common between 2 and 6 is going to be 6. So I need a plus and a minus 6. How about of my y's? Plus and minus 9. So which one's easier? I'm going to stick with my x's. Okay, so let's look at your coefficients. I have a 2 and a 6. So I'm going to keep the bottom 6, right? So that means what do I have to do to the top? I need to turn the top 2x into a negative 6x. So I'm going to multiply that by a negative 3. Yes? Do we all see that? Yay or nay? Okay, so this is a negative 6x plus 9y is equal to negative 18. Drop down the second equation, unchanging it. You're not going to change anything in it. And what are you going to do now? Add straight down, right? X's cancel out. The y's cancel out. So I have a 0 is equal to a negative 9. What did you say, Carter? Louder. Why? This is a false statement. Since that's a false statement, that means there's no solution. So therefore, these lines are parallel. Does that make sense? 0 never equals negative 9, so that's false. Do we all understand that? Okay, keep going. Are they lined up? Yeah. LCM of my x's. Plus or minus 6. How about of your y's? 4. Which one should we use this time? I'm going to do my y's this time. So I'm going to look at my coefficients. I have a negative 1 and a positive 4. So what do I do? I'm going to take the top equation and multiply it by a positive 4. So that's going to give me an 8x minus a 4y is equal to a negative 4. What do I do to the bottom equation? Simply drop it down. You know why? I already have a positive 4y there. So when I add straight down, I'm going to get 11x. The y's cancel out, are equal to 15 minus 4 gives you a positive 11. So x is equal to 1. How do I find y? Plug and chug. Does it matter which one I plug and chug to? No, it does not matter. So I have 2 times 1 minus y is equal to negative 1. So 2 minus y is equal to negative 1. Subtract the 2. Negative y is equal to negative 3. So what is y? Y is positive 3. So what is my POI? 1, 3. Do we understand? Uh-oh. What did you say? Why? Because you don't want to deal with those ugly fractions? He's not even looking at the problem yet. He just says, I'm not dealing with those fractions. That's great. That means I finally have trained your brain. It took a long time, but we got you there. That makes me happy. So I'm going to drop down the top equation because it has whole numbers, and whole numbers make me happy, right? I'm simply going to multiply everything by 3 to eliminate the lovely little fractions. And now I don't even have to look at that anymore, do I? Now I have a new problem, right? A problem that makes sense to my brain. Now, what is my LCM of my x's? Plus or minus 10. How about of my y's? Which one? I'd stick with 10. So what am I going to do to this problem? Multiply the top by negative 2. Very good. So that's going to give me negative 10x plus 14y is equal to negative 8. Drop down the bottom equation. Again, you're not changing it. So what happens? Every single thing cancels and I have 0 equals 0. Is that sometimes, always, or never true? Always true. So what type of answer do I have here? This means I have many POIs because they are essentially the same equation. So you are going to write x comma y such that either colon or bar, it doesn't matter, 5x minus 7y is equal to 4. Done. Fun times, right? This is not hard. Agree? Okay, we're done with that method. That is elimination. That is really easy in my opinion. Okay? Substitution. Substitution. It is not. Substitution is that if you've been in any sporting event, a player goes out, a player goes in. Yes? Okay? Now, generally speaking, it would be really, really awesome if the player went in the same position. But 9 times out of 10, that never happens. A player switches a position, that means somebody else has to switch and do a different position. It happens. In mathematics, that's not the way it happens. What you're going to do is you are going to pick a variable, and you're going to solve for that variable, and you're going to get an expression. You're going to plug that expression into the second equation every place you see that letter. But here's the kicker. Substitution is best used when your coefficients are 1, because then you have no fractions. If you take and you solve a variable for a lovely little variable and you get a fractional expression, you're having to plug a fraction into something that makes very messy distributing, right? With that being said, here we go. I'm going to tell you always and forever to take and choose the equation that has a coefficient of 1. So look at the first equation. I have a coefficient of 1y. In the second equation, I have a coefficient of 1x. It does not matter which equation you choose. If you choose equation 1, I tell you to solve for y. If you choose equation 2, you need to solve for x. It makes things pretty. If not, you're going to have fractions. So who wants to take equation 1 and solve for y? Okay, so we're going to take equation 1. Now, do you see my breadcrumbs? You guys get lost in the middle of a problem all the time. Elimination, it goes straight down. You don't have to worry about it. It makes sense. Substitution can kind of go all over the place, and you guys don't think downward. So what I like to do is I like to leave breadcrumbs there to know exactly what I did. So we're going to take equation 1, which is 4x plus y is equal to 5, and we're going to solve for y. So y is equal to 5 minus 4x. Box that in. That is the expression. Now I'm going to take equation 2. I'm cheating. Now I'm going to take equation 2. And I'm going to plug and chug. PNC, plug and chug. X minus 2y is equal to 8. Every place you see a y, you are going to plug the expression 5 minus 4x in for it. Do we see that, yes or no? And simply solve. X minus 10 plus 8x is equal to 8. 9x minus 10 is equal to 8. Add the 10. 9x is equal to 18. X is equal to 2. Yes? Are we all good? Now, how do I find y? Where do I plug and chug into? Well, dude, I already solved for it. I may as well use my box, right? Make my life really easy. 5 minus 4 times 2. 5 minus 8, negative 3 is y. So my POI is 2, negative 3. Do we see that, yes or no? Super easy. Next one. That's nasty. Why is this nasty? Do I need to go back? Were you done? Yeah. Are you sure? Yeah. Okay. Were you done? No? My bad. My bad, my bad, my bad. You good? Are you sure? Yeah. Okay. Is everybody good? Okay, why is this one not fun? And there's no blood coefficient on any of them. So choose your poison. Which equation for which letter? It really does not matter. Eeny, meeny, miny, moe. Hunter, what do you want? Sounds like a plan. So he says he's taking equation number 1 and he's solving for x. So 3x minus 2y is equal to 16. So that's 3x is equal to 2y plus 16. So x is equal to 2y plus 16 over 3. Keep it as one fraction, not 2. It's a whole lot easier to plug in one fraction rather than plugging in two fractions. Do we all understand that? Okay, so now I've used equation 1. Now what do I have to do? I have to use equation 2. And I'm going to plug in shove. So equation 2 is 4x minus 3y is equal to 23. Every place I see an x, what am I plugging in? That nasty, right? So 4 parentheses, 2y plus 16 all over 3 minus 3y is equal to 23. Yes? Do we know how to do this? Yes, you do. Because all you have to do is put this over 1, and that's 4 parentheses 2y plus 16 all over 3 minus 3y equals 23. Do we like fractions? So what should I do? Multiply everything by 3. So if I do that 3 cancels out, and I'm left with 4 times 2y plus 16 minus 9y is equal to 23 times 3 is 69. Can I make it look prettier? Sure. I'd have been done with this if we did an elimination, though, huh? Do you get that? Had we done elimination with this problem, we would be done. I'm not a substitution fan either. I prefer this one, or an elimination. 4 times 2 is 8y. What is 4 times 16? Minus 9y is equal to 69. What is 8y minus 9y? Negative y plus 64 is equal to 69. Go ahead and subtract the 64. Negative y is equal to 5, so y is equal to negative 5. So now that I found y, how do I find x? I'm going to go right to the box, and I'm going to plug it in. 2 times negative 5 plus 16 over 3. Negative 10 plus 16 over 3. 6 over 3 is 2, and that's x. So my POI is 2, negative 5. That's nasty, isn't it? Who wants to do that work? There's so many. I just chose the way he told me to do, right? I mean, there's really not a nice way to do it. I mean, there's many ways to do it. Think of how many different ways are there to kill a deer? How many different seasons? Oh, I don't know. The end result, the deer is dead. Okay, hey, my time. Are we listening? Problems 1 through 6. No work goes on here except for your answers. Show all work on a separate sheet of paper and put only your answers here. I see you all staring at me and giving me that evil glare. I don't care. I won't grade it. No bet. Okay, problems 1 through 6. Solve system by elimination. Show all work on another piece of paper and place the answer on this worksheet. The top is all elimination. 6 problems. The bottom. Solve each system by substitution. Show all work on another sheet of paper and place the answers on this worksheet. Please look at substitution. Look at number 7. What do you notice? It's already solved for t, so box that in and plug and chug, right? Number 8, wasn't that really nice? There's coefficients of 1. Number 9, coefficients of 1. Number 10, coefficients of 1. Number 11, coefficients of 1. And number 12, coefficients of 1. I didn't make any of them nasty. Tomorrow's, there's nasty ones. Okay, the rest of the period is yours.